title of this section is Systems of Nonlinear Equations. It sounds really intimidating. You know, you tell your friends you're solving systems of nonlinear equations, they go, wow. They'll think you're really, really smart. It's not all that bad. What's going to go on in this section is that you're going to have a system of equations to solve. It's just that they're not necessarily straight lines anymore. You get stuff like you do in problem number 8, which is x squared minus y equals 1, and 2x squared plus 3y equals 17. Now, if you wanted to graph both of these, you have a couple options. You can put them in Desmos. And by the way, I've talked a lot about Desmos. Did I ever mention that, and this will surprise you, they got an app for that? You can actually download Desmos to your phone. So it's pretty cool. Now, in any case, if you wanted to graph this on your graphing calculator, you'd have to solve for y. So in the first case, it would be y equals x squared minus 1. In the second case, it would be y equals 17 minus 2x squared divided by 3. So it's not going to look pretty either way, but can you tell me what the general shape of these things is going to be? Yeah, they're both going to be parabolas. Now, when we're solving system of equations, geometrically, what were we looking for? What are we trying to find? Intersections. So you've got two parabolas. One's facing up and one's facing down. They can intersect themselves at a number of points, but it's still the same idea. You can solve it with addition, substitution. You can even use Cramer's rule or inverse matrices. But let's just try and do it as simple as possible. In this case, because I got a minus y here, in fact, it's pretty easy to isolate y. Y is x squared minus 1. Let's plug that in here and see what good that does us. Well, that's going to be 2x squared plus 3 times x squared minus 1 equals 17. Did that gain me anything? Did that help out at all in any way? Yeah, I lost the y. And what's nice is that even though it's not necessarily a pretty equation, it's still a quadratic equation. At the end of the day, you've got the quadratic formula that can solve a quadratic equation. So 2x squared plus 3x squared minus 3 equals 17. Or 5x squared minus 3 equals 17. Do I need to pull out the quadratic formula to solve this one? No. 5x squared equals 20. X squared is 4. Ooh, be careful. Ah, very good. Plus or minus. Good job. X is plus or minus 2. Now, it's important to get both solutions because we're going to see that these two curves intersect themselves at two different places. So, at x equal 2, let's figure out what y is going to be. Y is going to be negative 2 squared, or excuse me, positive 2 squared minus 1. So y is going to equal 3. And the same thing is going to happen at negative 2. Plugging that back in up here, negative 2 squared minus 1 is also going to be 3. So our two solutions are 2 and 3, and negative 2 and 3. Graphically, you can see those two solutions on your handout. Negative 2 and 3, and 2 and 3. Now, depending on how these parabolas are facing, you could get as many as 4 different possible solutions from a system of equations involving two parabolas if one of them is facing, say, sideways.
But if they were facing sideways, why not have to do this with a single line, which means it only intersects at 2 points?
No, in fact, well,
Because you're the inverse, you'd make it a square root, which means you only have one line.
you can get 4 solutions out of 2 parabolas. You just have to have one facing sideways, and then one facing up or down. So nothing too much different in problem number 8. I mean, if you really wanted to, I think it'd be a lot more work. You could set up an inverse matrix to solve, but when you solved, what you'd be getting would be the solution for x squared and the solution for y. You wouldn't be getting the solution for x. Let's try some more here. Problem number 12. Any questions on 8 before I move on to number 12? All right, so problem number 12. 2x squared plus 4y equals 13. And x squared minus y squared equals 7 halves. Well, the first graph, you could probably tell me what that one is. At least I hope you could. That one's going to be a parabola. The second one, this is going to be reaching back to your work in Math 1150. Does anyone recognize what this shape is going to be? Yeah, a hyperbola. Now, we don't necessarily have to know what the shapes are in order to solve this system of equations, the system of nonlinear equations. We did substitution for the first one. Let's use the addition method for the second one. What if I were to take that second equation and multiply it, say, by -2? If I multiply this by -2, I get -2x squared plus 2y squared equals -7. And I'm going to add that to the first one. 2x squared plus 4y equals 13. You just got to be careful with adding these two together. You do get a little nice cancellation. The x squareds cancel. Can I add these two together? No, they're not like terms. One of them's a y, one of them's a y squared. So you just get 2y squared plus 4y equals 6. Okay, not so bad. Let's move the 6 to the side. 2y squared plus 4y minus 6 equals 0. I'd factor out the 2 first. Y squared plus 2y minus 3. Bless you. Factoring is your best friend, so we'll factor to solve this one. And we get two solutions for y. Y equals -3 and y equals 1. Are we done? Let's take a look at the graph of this stuff. How many solutions do you expect? 1, 2, 3, 4. So we expect 4 solutions. We've only got a value for y, 2 values for y. Let's see what's going to go on beyond this. If I set y equal 1, how am I going to find the other solutions or the value for x? Plug it back in. Now you have your choice of either the first equation or the second equation. My money's on the first one. What do you think? Let's go with that one, yeah. No fractions. Bad news, right? So 2x squared plus 4 times 1 equals 13. So 2x squared equals 9. X squared equals 9 over 2. X equals plus or minus the square root of 9 over 2. Okay. So those are our two solutions. Now, what's that translate to in terms of coordinate pairs? I'll have one at minus the square root of 9 over 2. And what do we use? We use y equals 1. And then positive the square root of 9 over 2 and 1. Now, if the author saw me, he'd probably be cringing because I haven't rationalized the denominator here. All right, I'm not going to worry about that right now. Let's get the other solutions. So if I set x equal to, excuse me, if I set y equal to negative 3, 2x squared plus 4 times negative 3 equals 13. 4 times negative 3 is negative 12. So that's going to be 2x squared equals 25. And boy, it'd be nice if it was just x squared equals 25 instead of 2x squared equals 25. But it is what it is. 25 over 2. I get x is plus or minus the square root of 25 over 2. Now, if you want to take that 25 out of the root, that's fine. It's 5 over the square root of 2. Fine. Two possibilities here. Negative root 25 over 2 and negative 3, and positive root 25 over 2 and negative 3. We can come up with some numerical values and see if those match. Let's just try and do that. So for the first one, I get about negative 2.12. Does that seem about right? So, yeah. It's a little bit to the left of negative 2. So that seems pretty good. So that's your negative square root of 9 halves and 1. Here's your positive square root of 9 halves and 1. Now down here I get negative square root of 25 over 2 and negative 3, and positive square root of 25 over 2 and negative 3. You can check, numerically speaking, this is about negative 3.53, and that looks pretty reasonable compared to, the graph. We had something certainly between negative 3 and 4, and again something between 3 and 4 over here, so these points look reasonable. And I hope that you take the time to make a little critical assessment of some of your answers. So we solve one by the addition method and one by substitution. You're free to solve these, pretty much any way you want, short of the neighbor's paper method. All right, I'm not really fond of that one. But if you keep your eyes on your own paper, then that's great.
So I can use the neighbor's method as long as I keep my eyes on mine?
We'll give you a special seat. All right. How are we looking on the first two? Let's do a few more. In fact, 3 more and we can finish out the section. So let's try problem number 26. So x plus the square root of y equals 0. And y squared minus 4x squared is equal to 12. What would you do for this one? Substitution or addition? I guess that's your first choice. Addition?
Well, if you rearrange the second equation, make it negative 4x squared plus y squared equals 12. Couldn't you square the top one?
Well, you can't exactly square the top one and as it is right here.
Right.
So, I mean, it's a good... All right. What if we move the square root to the right-hand side? Then you have x equals negative the square root of y. Does that suggest or imply anything? It's a good suggestion. Now what would we do? What method are we heading towards? Substitution or addition? Substitution. So we know what x is. Let's take that expression and substitute it into the other equation. So take that value here and substitute it in here. So we'll get y squared minus 4 times something squared equals 12. And that something is negative the square root of y. Katie, square that out for me if you would, please. What do I get here? How does this simplify? All right, and what do I get? What's my new? 4y. Good. So y squared minus 4y equals 12. Well, this isn't so bad. At least that's an equation we can solve. How would you solve this quadratic equation? Yeah. Came from this negative here. Well, when you square that, keep in mind that you're going to multiply it by itself. So a negative times a negative would be a positive. Was there another question? Okay. So we're going to factor this, right? Move the 12 to the other side. Y squared minus 4y minus 12 equals 0. Factors as y minus 6 times y plus 2. How many solutions do we expect to our equation? We could get up to 4. But take a look at your handout. See if you can't predict how many solutions we'll actually get. Yeah, looks like we're just going to get 1, right? Because when you look at the two graphs, they all intersect at 1 point. So let's see. We get y is 6 or y is negative 2. We should use these values to find x. So x equals negative the square root of y. So at y equals 6, we end up with x is negative the square root of 6. Okay, so that's one solution. So negative root 6 and 6. What's going to happen at y equal negative 2? Yeah, it's imaginary. So basically there's no solution, no real solution. You're not going to be able to see this point on your graph. We're only going to be able to graph in real numbers, not in imaginary numbers. So that's it. There's one and only one solution. So we're kind of running the gamut here so far. We've had 2 solutions, 4 solutions, 1 solution. Let's keep going. Are you okay with what we did with problem number 26? 2 more problems, then I'll get you on a nice break. Let's try problem number 28 next. X squared plus 2y squared equals 2. And 2x squared minus 3y equals 12. Wait, 15, thank you. thoughts on this one? Yeah, multiply the top by -2. Yeah, I think we're going to go back to the addition method because we can quickly get rid of the x squared terms here. So if I multiply the top by -2, I get -2x squared minus 4y squared equals -4. Added to 2x squared minus 3y equals 15. So I get minus 4y squared minus 3y equals 11. Yuck. Well, let's move everything to the right-hand side. 4y squared plus 3y plus 11 is going to equal 0. So I just moved everything to the right-hand side. And let me just do a little bit of work on this. Trying to do the minimum amount of work that I can to arrive at the solution to my problem. Does anyone figure out a way that this thing factors? Neither have I. All right, so you're in good company. So if it doesn't factor, then what should we do? Quadratic formula. Now, I want to get done with this problem as fast as I can, so let's just take a look at this. What's b squared minus 4ac? Do you recognize that part? Should be... All right, so it's part of the quadratic formula, but it's the part that's underneath the radical. What's b squared minus 4ac going to look like here? It's going to be 3 squared minus 4 times 11. Well, let's see. No, it's going to be 16 times 11 is 176. So, -167. But what's the important observation about this? The important observation is that that's less than 0. Why is it important? If that's less than 0 underneath the root, yeah, you've got imaginary solutions. So no real solution. So that's as far as we need to go. There's no real solution. We're not going to work with imaginary solutions here. We want to see where it actually crosses, not where it crosses in the complex plane. If you look at our graphs, they don't intersect. One's a parabola, and inside it, you've got a nice little tiny ellipse. So no solution. Now, had you solved the quadratic formula all the way, you'd get two complex numbers. And again, there's no real solution. Last one, problem number 30. X to the 4th plus y to the 3rd equals 17. 3x to the 4th plus 5x cubed, excuse me, 5y cubed equals 53. Number 30. Now, if you wanted to, you could solve this with a matrix system of equations because these variables are the same in both sets of equations. You could set up 1, 1, 3, 5, and then you'd have x to the 4th, y cubed equals 17 and 53. The only thing that you have to keep in mind is that when you're all done, your solution wouldn't be x and y. What would your solution be? you'd have x to the fourth and y cubed. You'd still have to take the fourth root and the cube root to finish solving. So you can do it that way. I'll point it out. Let's actually do it kind of more of a traditional approach, what I would expect most of you to do. And that would be to multiply the top equation by what? -3. So we'll do the addition method. Top equation by -3 gives me -3x to the fourth minus 3y cubed equals -51. So we end up with 2y cubed equals 2. So y cubed equals 1. What does y equal? Actually, just 1. You would have the plus or minus if this was an even number. But since it's an odd number, it's just 1. If y equals 1, we got x to the fourth plus 1 cubed equals 17. Subtract 1 from both sides. Can anyone tell me what x equals? Yeah, all right. Yeah, this time you need the plus or minus. All right, so if it's even, and you're taking like, the reciprocal power to come up with a root, so the fourth root of 16, we need the plus or minus, because that's an even root. For the odd roots, you don't need the plus or minus. So that tells me there's two solutions, 2 and 1, and -2 and 1. And that's precisely, boy, this was a pain to try and figure out how to graph this on a graphing calculator and on Desmos. But there's your two solutions. Kind of two pretty far extremes, -2 and 1, and 2 and 1. So two solutions. That's it. All done with section 10.8. All right, so for homework, try, let's see, I'm going to have to get back to you on the homework. I don't have that yet, so I'll put it in the notes, and let's take a break.